There are a few ways in which you can go about sketching out quadratics, and you don't necessarily need to find the turning point by completing the square and things like that. A couple of things you need to be aware of, okay? Obviously, just initially, the A value there will tell me whether it's a minimum or a maximum, whether it's an upright parabola or an inverted parabola. To find our x-intercepts, again, calculate the y-intercept, we put x equal to 0. To calculate the x-intercept, you put y equal to 0. This one here, typically you're going to have an ax squared plus bx plus c equal to 0. Now, you could complete the square to find a turning point and or complete the square to find the x-intercepts. We can use this formula here. Minus b on 2a will give you the x-coordinate of the turning point. And once you've got that, you can just substitute that into the y expression, or you can memorize that rule there. I tend to get that value and then substitute it into that expression. Or if you've got the x-intercepts, we just average them. So if your intercepts are at 1 and 3, well, the average of 1 and 3 is 2. So your turning point is in the middle, because don't forget your graph is symmetrical. So there's a couple of different approaches we can use. So let's have a look at some of them. Okay, so for me, my first step is typically to write it in factored form. So now straight away I know my x-intercept, if I put y equal to 0, I get x times x plus 6 is equal to 0. So I get x equal to 0 and x is equal to minus 6. So there's my intercepts, 0, 0, negative 6, 0. Y-intercept, put x equal to 0, I get 0, which is what we expected. And now my turning point, well, I can get my turning point by a number of ways. I might actually just opt for the turning point will be at minus b on 2a, which is equal to negative 6 over 2 times 1, which is at negative 3. So my turning point is at negative 3, and at x equal to negative 3, y is equal to negative 3 squared plus 6 times negative 3, which is equal to negative, positive 9 minus 18, which is negative 9. So my turning point is at negative 3, negative 9. So if I bring that together, since everything's down a little bit, I might bring that up there. And I've got a turning point there at 0, an intercept at 0. We'll call that negative 6, so negative 3 is about there, halfway. So if we're going up in 2s, 2, 4, 6, 8, 9, so maybe there. So if I sketch my graph, I'll get negative 3, negative 9. So you can see there we've got our turning point without necessarily completing the square. I could have. I could come over here and just complete the square, x squared plus 6x, halve it, and subtract it. So I get x plus 3 all squared minus 9 is equal to 0. So you can see my turning point is at negative 3, negative 9. And I could even then solve that equation, x plus 3 all squared is equal to 9. X plus 3 equals plus or minus 3 by square rooting. So x is equal to negative 3 plus or minus 3, which is equal to 0 and negative 6 for my intercepts. So again, I could use a number of different approaches. It just depends on which method you prefer. So look at the next example. Again, first step for me, so x-intercepts, let's put y equal to 0. So I need to solve 0 equal to x squared plus x minus 12. Well, it looks like 4 and 3, doesn't it? 0 is equal to x plus 4, x minus 3. Therefore, x is equal to negative 4 and positive 3 is the intercepts. So negative 4, 0, 3, 0. Let's complete the square this time, just for something a little bit different. Let's go with, where are we going to go? We'll go x squared plus x, halve it and square it. So it's plus a half squared minus a half squared minus 12. So I get x plus a half all squared minus a quarter minus 48 on 4. So I get x plus a half all squared minus 49 on 4. Therefore, the turning point is at minus a half, negative 49 on 4. So let's sketch our graph. Let's put in some axes. Turning point this time is at, we'll call that minus a half, minus 49 on 4, which is about minus 12. X-intercepts are at, where did we say they were at? Negative 4 and 3. So we'll call that 2, 4. So we'll call that 3. Negative 2, negative 4, negative 4. So our graph looks a bit like that. The only thing we haven't worked out is our y-intercept. So if I put x equal to 0, y will equal negative 12. 0, negative 12. So there's our key points. Slightly different approaches, but equally valid.